mean of sample 1, and we do some columns. And the mean of sample 1, I said it's 49.2. So we take the mean, the width of the leaf, and we subtract it from the mean we calculated. Now we find that 35 minus 49.2, you get negative 14.2. Then 47 minus 49.2, you get negative 2.2. And you just go like that up to the last sample, the last sample number 15. Then after I finish that, introduce another column where you are going to square this. So like negative 14.2, you square it, you get 201.64. And you fill that column from the beginning up there. You got the second one, negative 2.2, you square it is 4.84. Then you do it up to the last one. And then you do the same to the sample 2. You calculate the mean of sample 2 from the beginning to the last one. Then when you finish, you do the same. Then after you have finished, you calculate now the standard deviation. And how do you calculate the standard deviation? You do the summation of this column where we have x minus x bracket squared. You do the summation down here, the summation down there, and the summation here. So you calculate the standard deviation for each sample. So the standard deviation for the first sample is 16.75, and the standard deviation for the second sample is 19.19. Then, after you have calculated that, then you come and calculate the test, the student t-tests. And you calculate now the t-test for the list, and that's see what you do now. You subtract the two means. Remember, the mean for the first sample was 49.2. You subtract from the mean of the second sample, which was 28.8. Then there is a denominator down here. You have to get the standard deviation, square it, then divide it by their mean at their sample number, plus the standard deviation of the second sample, square, then you divide it by the sample numbers there. So the standard deviation for the first sample is 16.75, you square it over 15, and plus 19.15 squared over 15. So when you can work it independently here, that's what I've done independently here to work independently. So you get to 80 over 6, to 80.6 over 15, which is 18.70. Then the second sample is 368.4 all over 15, which is 24.56. Then thereafter, you put them together again and you get the square root. After you have added them together to get for 3.26, and the square root, it will be 6.577. Then you calculate the t statistic will be 3.101. Then when you finish that, you now come and calculate the degree of freedom. And we are saying the degree of freedom equals to the number of the number of the samples in sample 1 and the number of samples in sample 2, and you subtract 2. So in this case, the number of samples in sample 1 were 15, and in the sample 2 were also 15. So 15 plus 15 minus 2, you get 28. In that, you finish that, you get the t statistic tables up on the row, the row above. Before you begin every other thing, it's called the p value or the alpha value tables. But because we are using 0.05, we locate where 0.05 is on the table, and on the sideways of the column we have the degree of freedoms. So we locate where 28 is, and when we locate 28, we move across and we move from up where the 2 of 0.05 and 28 will meet the confluence is our value, and that value is called critical value. So we set up the rule now, and the rule is if the t-value is greater than the critical value, then we reject the null hypothesis. And we look at the t-value we calculated is 3.1101, while the critical value is 2.048. So the t-value is greater than the critical value, then we reject the null hypothesis and we accept the alternative hypothesis. Up to that level, I think we are clear.
Yes, Doc. Thank you.
So I have the data here.